Okay, so the first thing that you're going to want to do to start your analysis is you're going to make a table of the concentrations and their corresponding absorbances. After you do that, you can go ahead and select this, select your data, and then you're going to want to insert a chart, but you want to do a scatter plot. So this is the one that you are wanting. I've already created mine, but I'm just going to show you a couple of things about that. So let's go ahead and make a new one. Okay, so after we do that, you'll want to make sure that you take your data and you're going to add a trend line here. Okay, so it should be linear, and you want to go down here and you're going to set the intercept at 0, because we know that when there's 0 concentration, we should have 0 absorbance. That's why we zeroed the instrument. And we also want to make sure that we are displaying the equation on the chart for our trend line, as well as the R-squared. So the R-squared helps us know how linear the line is, like how well does that trend line fit the data. Okay, so afterwards, there's a couple of things that we want to make sure that we're adding here. We want to make sure that we have a nice title here. So go ahead and, it should be something that's very indicative of what is being shown on the chart. So for mine, I put copper nitrate concentration versus absorbance. Okay. You'll also want to make sure that you're adding your axis titles. And so this is found under chart design here, and you're going to go over to add element, and then you can do both your horizontal axis as well as your vertical axis. Okay, and you want to make sure that when you are putting your values or the names of the titles here, that you're labeling it with the unit. Okay, don't worry about that for absorbance. It is a unitless value, so there's actually no unit associated with it. Okay, so after you have done that, you'll want to make sure that you have you've put down what the absorbance was for your unknown sample. Okay, so in order for us to find out what our concentration was, we have to make sure that we are taking this value here, so the absorbance that we got, and we are going to divide it. So essentially we are solving for X in our equation. So we're dividing it by the slope of that line. Okay, so that's going to give us our concentration. Okay, after we have the concentration here of the unknown sample in molar, we want to write down, okay, we know that our sample volume was 100 milliliters. So here I just put it in terms of liters. Because what is molar? So molar is moles per liter. Okay, so I just did that ahead of time. All right, so we'll want to calculate how many moles of copper ion are in the solution. And so you get that from multiplying these two values together. So as we see up here, so we've multiplied those together. Okay, then we know molar mass, we get that from our periodic table. And then we have the original sample mass that we weighed out before we dissolved the brass. Okay, we got to make sure that we write that down there too. Okay, and so the mass of the sample, the mass of the copper in the sample, we can solve that by multiplying the grams per mole of copper by the amount of moles of copper ion that we solved for earlier. So now that we have the mass of that, we can go ahead and calculate the percent mass of copper in the entire sample. So we go ahead and we're going to divide our copper mass by the total mass. Okay, and so that's what we have here. And so you want to make sure it's in terms of percent. In order for it to show up like this, you can go ahead and just click the percent sign so you don't actually have to separately multiply by 100 to get it a percent. It'll just automatically do that for you. Okay, and then so the actual percent copper in this brass is 70%. Okay, so we want to find out what is the percent error. Okay, so in order to find percent error, we are going to take these two guys, what we got for the calculated percent copper versus the actual percent copper. We want to subtract those and divide it by what the actual percent is. Okay, and so that's going to give us 5.4% error for this. Okay,